This is a recap of Bay Area JavaScript interview meetup on August 23rd. The first question is number of islands. Before you jump in joy and think, oh, I already know this question, number of islands has many variations, so this is one of the variations. Given a 2D matrix, each cell only has number of 0 or 1. They are number, not string. Return the number of islands, where the number of islands is defined as all the ones that are adjacent is counted as one island. So these 5 ones are one island. These 2 are one island. Notice you can go diagonal also. So this one can seek for neighboring islands in these 8 neighboring grids. This is another island of 5. This is the last island of 4. So this matrix will return 4. Pause the video and see if you can solve it. What is the intuition here? We should do depth first search on every cell. Now there are 2 things that we need to take note of. The first thing is we do not want to visit a cell more than once. So you need to have some sort of mechanism to mark a cell as visited. Another thing is boundary checking. When you are at this cell, for example, when you are checking for top left or top right, you will be out of bound. So there needs to be some boundary checking. Similarly for every first row, last row, first column, last column. When you are seeking for neighbors, you will go out of bound. So you need to handle that. Okay. Now let's define the thing we want to return as result. Now, because we want to do depth first search on every node or every cell, we just loop through. Well, let me use row to be more explicit. Then is column. Now, depth first search, we need a helper function. And call inside here. Now, what shall we put in? We should put in the row and column, right? And receive it. So now we handle boundary. If you are less than 0, or you are greater than equal to row, C will be greater than equal to column. Now let's do a return here. Now what shall we return? We can return a Boolean where if you are not a valid cell, we return false. Also, if we have already visited you, we also return false, which means if we return true, our result will +1, which means we have discovered a new island. You can just do res plus equals to this, right? If it's false, we do not increment island count. If it's true, we discover a new island. How do we know it's already visited? If it is 0, that means we already visited. Then you just rewrite it as 0. If you reach this line of code, it means we have not visited this cell before, and this cell value is 1. To mark it as already visited, you just overwrite the value is 0. Seek for neighbors. So you go from -0, 0, and 1, right? On the row side. Then on the column side, you do a r plus I and c plus j, right? And in the end, you return true. Let's see what we got. 4 is correct. Let's make this 1. So if this is 1, there should be 3 islands. 3. So it looks like it works. So this is the final code. The second question is, find the number of occurrences of a given word in a grid. So if the word is geeks, you want to find the occurrences inside the grid. Now, this is one, this is another one, this is another one. Note, you can, assuming you start off at G, you can go from any direction, 8 directions, right, up, left, down, and the diagonal. But once you pick a direction, you must follow through. Meaning GEEK, you cannot match to this S. All right, you can only match to this S. So once you pick right, you must follow through. Similarly, GEK, you cannot match to this S. GEK, if I change this E to S, is no. Same thing, if this is S, not allowed. Okay, the next case is, if my word is EEE, you have one match here, one match here, because this is diagonal. Now you can go back, meaning another match, the reverse direction, and another match here, the reverse direction. Similarly, once you pick a direction, you cannot change, you must commit. So this EEE is not allowed, right? Because you pick down, but you change to diagonal right. This is not allowed. Just to illustrate the point further, once you commit to one direction, for example, you go down, you must go down, follow through. If you want to go diagonal up, you must follow through. Molecule is a valid case. And of course, ELUCE OM is also another case. We are only searching for one word, so this is just illustration. You are not searching for 5 words at once. You're only searching for one word. So let's say you're searching for small, there's one occurrence here. Because we need to follow through the direction, let's suppose this R become L, it is still one occurrence because you must follow through. Pause the video and see if you can solve it. So what is the intuition here? It's the same as the previous question, number of islands. You do a depth first search on every cell. So let's set it up. Res is 0, return res. Have a helper function called helper, taking a row and a column, and you call it on every cell. Let's make it more explicit by calling it row less than greater than length, which is row number. And column. You call a helper. Now, same thing, check out of bound. Greater than grid dot length or c greater than or equals to grid 0.length, return false. Out of bound. Okay, now the different thing between this and the previous question is, what is the success condition? The success condition is we found all the match. Well, we can assume you start off with 0 match, right? Once you match the length of the word, you successfully match, so your result +1. So you can pass in a 0, and I receive it as current. So this current, once my current equals to word.length, return true, right? You start off with 0 matches. Now we do something. Once we match everything, we return true. What other circumstances is this not a match? You are not a match when the current cell does not match the current character that we are seeking. Current cell doesn't match current character. Meaning if my matrix, if my grid RC not equal to word cur, you are not a match, right? Okay, so where are we seeking? We are seeking for 8 directions. So let's make it directions, make an array of 8. I am bad at typing. So you go, just initialize. Make sure you don't put 0, 0. So it's 0, 1, because 0, 0 is myself. Now Prettier will format this. There we go. You need to pass in what is the direction that I'm seeking to the helper function. And in order to do that, and you need to seek for every direction at every cell. So you can do a direction stuff for each current element. You can pass the direction in. So let's receive it, call it D. So D is what direction that we are going. This grid RC is the current cell. So where are we going next? We will go R plus direction 0, C plus direction 1. Now the current +1 and D, right? Then you just return it. Oh, I forgot to res plus equal to 3. That is correct. Let us use the other test case. The EEE test case is supposed to return me 4. So it's correct. I hope you understand what this code is doing. So let me zoom it in. The success condition is I match everything. So cur just keep track of which character of the word I am looking at. If the current character doesn't match, it's false. If it match, we follow through the direction. Now D0 is where are we going row-wise. D1 is where are we going column-wise. So the updated row will be R plus D0. Updated column will be C plus D1. Because we match the current, so in the next call stack, we match current +1, and D doesn't change. I hope this code makes sense to you. This is the full code.